Welcome to a quiet exploration of nature's standard of time, where we observe the silent mechanics of flowers and the steady, delicate rhythms of pollination. As the opening card fades to darkness, allow your surroundings to grow still, letting your eyes rest comfortably as the image slowly dims. There is no rush tonight, no urgent destination to reach, only the slow unfolding of petals and the quiet passage of hours measured by the natural world. Long before mechanical clocks ticked inside silent rooms, the landscape held its own quiet sense of time, inscribed upon leaves, stems, and blossoms. In the gentle stillness of the garden, flowers respond not to human schedules, but to the subtle shifts of sunlight, atmospheric pressure, and atmospheric moisture. Each morning, as the earth turns toward the light, blossoms across fields, meadows, and woods undergo microscopic movements, awakening in perfect alignment with the arc of the sun. In the mid-18th century, human curiosity sought to observe and catalog these predictable botanical movements with quiet reverence. In 1751, Swedish botanist Carl Linnaeus designed the asterisk horologium Flori in Uppsala, a living floral clock composed of plants like dandelion and hawkweed that unfurled and folded their petals at precise hourly intervals from dawn until late afternoon. Linnaeus noticed that each species possessed its own steady internal rhythm, opening its petals at a specific hour in the early light and quietly tucking them away as the light shifted later in the day. The bright, radiating heads of dandelions would expand under the first warmth of dawn, while various species of hawkweed would follow at predictable moments throughout the daylight hours, closing again well before the evening dampness arrived. This living horologe demonstrated that time was not merely an abstract human construct, but an organic cadence woven directly into the living tissue of plants. The opening of a bloom was a silent invitation to the morning air, while its closing was a protective shield against the cool moisture of the impending night. These physical transformations are governed by delicate cellular mechanisms operating beneath the surface of each petal, governed by changes in fluid pressure and cellular expansion. As gentle warmth reaches the plant, water travels through cell walls in deliberate, rhythmic waves, causing tissues on one side of a petal to expand slightly faster than the other. This subtle imbalance allows the blossom to open with effortless fluidity, revealing its hidden center without making a single sound. When darkness approaches or temperature drops, fluid recedes and the petals curve back into a tight, protective dome. This continuous movement ensures that pollen remains dry and viable, safe from heavy rain or midnight dew, while preserving energy for the moments when daylight returns. In this quiet, orderly world, every plant moves according to a timeless design, maintaining a peaceful equilibrium with the atmosphere surrounding it. As we begin our reflection on the mechanical beauty of plant life and pollination, let your breathing settle into the slow, steady rhythm of the night. There is comfort in knowing that across the globe, without fail. The natural world continues its silent work, closing its blossoms at twilight and waiting patiently for the warmth of another morning. Across the natural world, plants move to quiet, unseen clocks, measuring the passage of hours, not by the ticking of mechanical hands, but by the subtle opening and closing of delicate petals tuned to light and atmosphere. The timing of each blossom is finely calibrated, ensuring that its soft petals open precisely when environmental conditions and pollinating companions are aligned. Far to the south, where slow river currents reflect the morning light along quiet tributaries of the Nile, the Egyptian blue water lily, Nymphea caerulea, opens its sky blue petals at 8:00 a.m. to float on the water's surface, then gently closes at noon and draws its stem downward until the following morning. This rhythmic dance with the sun creates a tranquil cadence upon the riverbank, as floating blossoms align with the rising arc of day. In those calm morning hours, a faint, sweet aroma drifts across the glassy water, inviting early insect visitors to land upon the gold-dusted center before the heat of midday arrives. As the sun reaches its peak, the flower closes around its inner sanctuary, drawing its stem downward into the cool shelter of the river until dawn returns, high above the warm river valleys, in contrasting realms where snow lingers late into the turning year. Entirely different physiological mechanisms awaken blossoms to their brief windows of life. On high mountain slopes where the air remains sharp and cold, plants cannot wait for winter ice to fully melt away. In early spring across the Swiss Alps, the alpine snowbell Soldanella alpina metabolizes stored sugars to generate subtle heat, melting a narrow chimney through the lingering snowpack, so its drooping purple blossoms can open into the crisp mountain air. This gentle process of thermogenesis allows the tiny, resilient plant to carve its own passage upward, while the surrounding landscape reposes under a heavy white blanket. The localized warmth in its tissues softens the crystalline snow above, creating a protective dome of clear air around the fringed purple bell as it emerges. By breaking through the crust ahead of the seasonal thaw, the flower gains precious extra days to offer its nectar to the earliest emerging pollinators in quiet alpine clearings. These contrasting strategies highlight the profound wisdom embedded within floral life, where every movement of a stem or opening of a corolla is bound to the subtle physics of survival. Whether buoyant upon tropical waters or melting a passageway through frozen snow, plants manage their internal resources with extraordinary conservation and patience. The movement of pollen requires careful coordination with wind currents, moisture levels, and the sleep and wake cycles of native insects. Nothing in these processes is hurried. Every expansion of cell walls occurs in harmony with shifting shadows and the gradual warming of the soil. as evening settles over both slow riverways and lofty mountain peaks. These floral cycles quiet down. The water lily rests safely beneath the surface, while the alpine snowbell sways gently in the mountain breeze, both anchored in the timeless, restorative rhythm of the natural world. In the high northern reaches of our world, where the summer day stretches across months without the interruption of darkness, the tundra moves to a remarkably slow and luminous rhythm. Across vast, quiet expanses of moss, weathered gravel, and permafrost, sunlight does not fall and vanish in sudden shadows, but instead drifts in a low, continuous circle around the distant horizon. The humble plants that anchor themselves in this fragile soil have evolved gentle, elegant methods to harvest every passing beam of warmth. Without the tall canopy of ancient forests or the sheltered softness of temperate valleys, polar flora must rely on delicate physical geometry and patient alignment to foster new life. Every slender stem and cupped petal becomes a quiet instrument tuned to the rotation of the sky, gathering energy to mature seeds before the brief Arctic summer yields once more to winter stillness. Among these resilient botanical creations, certain specialized blossoms share a deeply intimate relationship with the moving sun, functioning as natural solar collectors in the open landscape. In the high Arctic tundra of Svalbard, the parabolic cup of the Svalbard poppy, Papiverdolianum, slowly turns to follow the midnight sun, focusing solar rays onto its central carpel to keep its inner blossom up to 7 degrees Celsius warmer than the polar air. This quiet mechanical movement, known as solar tracking or heliotropism, relies on delicate turgor adjustments within the cells of the stem beneath the flower head, guiding the bloom along the solar arc throughout the 24 hours of constant daylight. The pale, bowl-shaped petals are contoured precisely like miniature satellite dishes, gathering diffuse sunlight and directing its subtle thermal energy inward toward the plant's reproductive center. Within this small, reflective basin, the internal climate remains surprisingly mild and sheltered, offering a localized oasis of warmth amidst the vast Arctic cold. This focused microclimate plays a crucial role in accelerating the internal development of pollen grains and seed-producing tissues, allowing the plant to complete its reproductive cycle during the short window of polar summer. Yet, the benefits of this parabolic design extend far beyond the plant's own physiological processes. In an ecosystem where chilly winds can easily render small insects sluggish and immobile, the elevated temperature inside the poppy bloom serves as an irresistible beacon of comfort. Small tundra flies and bumblebees, seeking refuge from the icy breezes that sweep across the gravel flats, regularly descend into the glowing center of the flower cup to rest within its radiant warmth. As these tiny visitors settle into the blossom, basking in the reflected light and sheltered air, their bodies gradually absorb heat, raising their core temperatures until they are active once more. While lingering in this restful refuge, the insects move gently against the poppy's central carpel and surrounding stamens, accumulating sticky pollen grains upon their legs and thoraxes. When they eventually take flight to seek another warm dish across the tundra, they carry this precious cargo with them, ensuring successful cross-pollination from one bloom to the next. In this tranquil alliance between solar physics, floral structure, and insect behavior, life sustains itself through quiet cooperation. The poppy offers a haven of heat in exchange for the continuation of its line, demonstrating how, even in the quietest, coldest reaches of our planet, nature moves with subtle precision and serene purpose. As morning light softly filters across the peaceful expanse of a quiet garden, the surface of a flower reveals a world of extraordinary precision. To a distant observer, floral petals appear as smooth ribbons of velvet or silk, painted in gentle shades of soft rose, warm cream, or pale violet. Yet beneath the gentle touch of morning dew lies an intricate, microscopic landscape carved directly into the outer cuticle layer of the plant tissue. Long before the sun reaches its zenith, these minuscule surfaces prepare for a silent, enduring dialogue with the passing breezes and visiting creatures. Nature does not rely solely on chemical pigments to produce guidance and color. Instead, it crafts delicate physical structures at scales far smaller than a single strand of silk, allowing sunlight to be bent, softened, and gathered in unique ways. In this quiet architecture, the physics of light scattering plays out continuously, offering an unseen beauty that operates just beyond the reach of human vision, yet remains perfectly aligned with the delicate senses of those who seek the blossom's hidden treasures. Among the quiet leaves of the summer garden, the Venice mallow, known scientifically as hibiscus trionum, unfolds its translucent, cream-colored petals toward the calm sky. On the surface of these delicate petals, researchers at the University of Cambridge discovered that microscopic, parallel ridges on the cuticles of Venice mallow. Hibiscus trionum petals act as diffraction gratings, scattering light into a subtle ultraviolet blue halo that gently signals foraging bees. This structural phenomenon does not rely on pigment synthesis, but rather on the precise, periodic spacing of microscopic surface grooves that separate incoming sunlight into its component wavelengths. To a foraging honeybee drifting through the still air, this subtle ultraviolet sheen functions like a soft, glowing navigational mark, highlighting the quiet path toward the center of the blossom where nectar and pollen await. The halo is entirely invisible to human eyes, existing in the specialized visual spectrum of pollinators, who perceive the flower surrounded by an ethereal ring of scattered light. This microscopic mechanism allows the plant to communicate across distance with minimal energy expenditure, turning ordinary sunlight into a beacon through pure geometry. As the afternoon unfolds in a quiet, unhurried rhythm, foraging insects move peacefully from bloom to bloom. Guided by these subtle optical signals etched softly into the grain of each petal, the interaction is deeply calm and effortless, reflecting a long relationship between flowering plants and pollinators shaped over countless seasons. Because these structural ridges are part of the physical waxy cuticle itself, they do not wash away with rain or fade in the summer warmth. They remain continuously active whenever sunlight touches the petal surface. When evening begins to draw close and the cool shadows lengthen across the garden, the petals of the Venice mallow slowly fold inward, closing up to protect their delicate interior components from the nighttime chill. The microscopic ridges grow quiet in the dim light, resting peacefully until the morning sun returns to awaken the garden once more. In this slow, reassuring cycle of light, form, and gentle contact, the natural world demonstrates how profound beauty and functional design can dwell in the quietest, smallest places. As twilight spreads its soft blue mantle across coastal dunes, a quiet stillness settles over the landscape, inviting every living creature to move at a slower, restive pace. In these dimming hours, when the warmth of the sun fades into the cool embrace of evening, the plant world shifts into a subtle, nocturnal rhythm. Leaves relax, stems soften under the gathering dew, and specialized blossoms begin to unfold their delicate, pale petals toward the rising stars. For centuries, we have observed plants as tranquil, silent observers of the natural world, anchored peacefully in the earth while seasons turn around them. Yet, beneath this stillness lies a quiet sensitivity, an intricate responsiveness to the gentlest atmospheric changes, the softest breezes, and the subtle murmurs of the surrounding air. As the evening deepens, the air carries tiny vibrations, the hum of a nocturnal breeze, the rustle of dry grasses, and the distant, rhythmic drumming of insect wings gliding low over the sand. In this peaceful dusk, flowers do not merely wait in passive solitude. They remain exquisitely attuned to the subtle soundscape of the night, listening to the delicate frequencies of life floating past their open blossoms. Among the coastal sands, where the waves whisper softly against the shore, the beach evening primrose opens its soft yellow corolla to the cool night air. Beneath the quiet surface of its bowl-shaped petals, a remarkable and serene dialogue takes place between plant and pollinator. When a passing bee approaches, the gentle frequency of its beating wings reverberates through the surrounding air, brushing lightly against the flower's delicate tissue. Studies on the beach evening primrose, Onothera drummondae, revealed that its petals act as acoustic receivers, detecting the low-frequency vibrations of bee wings and increasing the sugar concentration of its nectar by 20% within 3 minutes. This swift yet tranquil response allows the flower to offer a richer, sweeter reward precisely when a pollinator is near, conserving its precious energy until the exact moment of connection. The physical structure of the petal, curved gracefully outward like a tiny dish, captures these acoustic waves and translates motion into a chemical invitation without a single hasty movement. It is a quiet mechanism of remarkable elegance, where sound and sweetness interlock in perfect, restful harmony beneath the dimming sky. This quiet synergy between sound and sustenance reveals a deeper truth about the botanical world, that even in moments of apparent stillness, intricate processes of connection are constantly unfolding. As the evening primrose sweetens its nectar in response to the gentle hum of wings, the visiting insect is drawn closer, guided by both scent and subtle acoustic cues. The exchange is effortless and measured, demanding no hurried exertion from either the flower or its visitor. Once the pollinator lingers briefly and moves along its path, the primrose slowly returns to its calm state, continuing to cradle its nectar under the quiet watch of the moon. All across the landscape, countless similar cycles repeat in silence, each plant responding with delicate precision to the subtle rhythms of its environment. The night air grows heavy with the peaceful perfume of evening blooms, and the gentle mechanics of pollination weave a seamless tapestry of life across the sleeping earth, reminding us of the profound, quiet intelligence resting just beneath the surface of the natural world. In the late warmth of an undisturbed afternoon, the air between garden blossoms rests almost motionlessly, filled only with the faint, invisible currents generated by wings in soft flight. As a foraging honeybee flies through quiet air, friction endows its body with a positive electrostatic charge, allowing pollen grains from flowers like petunias to quietly leap across a half-millimeter air gap onto the bee's soft hairs before physical contact is made. The flowers beneath, anchored deeply in the cool earth, hold their microscopic pollen grains in expectant stillness, carrying a subtle electric potential that draws the tiny particles naturally toward the approaching visitor. This weightless transfer occurs in absolute silence, governed by fundamental electrostatic forces that bridge the tiny space between plant and insect. Long before the bee fully alights upon the blossom, hundreds of minute pollen grains are already securely gathered, guided by microscopic fields that make the exchange effortless, gentle, and peaceful. Elsewhere in the quiet garden, different species of flowers require a more specialized touch to release their hidden gifts. In the shady thickets, where blueberry bushes grow alongside wild nightshades, pollen is held securely within narrow, pore-tipped capsules, shielded from the passing breeze and casual visitors. To harvest this carefully stored dust, bumblebees extract pollen from blueberry and nightshade blossoms through buzz pollination, vibrating their flight muscles at a steady pitch near 400 Hertz, the note G4, to gently shake loose golden dust without harming the delicate petals. By disengaging their wings and flexing their thoracic muscles, they generate a soft, rhythmic hum that resonates through the flower's core. This precise acoustic frequency acts like a gentle key, causing the internal structures of the bloom to tremble just enough to release a cloud of fine golden grains, which settles softly upon the bee's velvety body, while leaving the fragile floral architecture completely intact and undamaged. These subtle physical mechanisms demonstrate how deeply interwoven the quiet routines of the natural world truly are. Whether through the silent attraction of electrical charges across a fraction of a millimeter, or the soothing musical resonance of a 400 Hertz vibration, the interactions between plants and insects rely on principles of incredible subtlety and physical balance. Neither process demands force, disruption, or stress. Instead, each relies on microforces working in complete harmony with the structure of the blossom. As the afternoon sun sinks lower on the horizon and cool shadows lengthen across the garden beds, these delicate physical exchanges gradually draw to a serene, comforting, and deeply satisfying conclusion for the day. The evening air cools down slowly, carrying with it the sweet, subtle scents of damp soil, crushed leaves, and resting foliage. The foraging bees begin their slow, graceful journey back to their hives, their bodies laden with the nutritious harvest gathered through friction, movement, and sound. Below them in the gathering twilight, the petunias, blueberries, and nightshades slowly relax, their reproductive cycles seamlessly advanced by the day's gentle, restorative encounters. A quiet stillness settles over every leaf, stem, and petal as the entire landscape prepares for sleep. Under the darkening sky filled with early stars, the natural world slumbers peacefully, comforted by the quiet, invisible balance of physics that keeps life turning with enduring grace and tranquility. In the quiet, sheltered corners of late spring gardens and damp woodland edges, where the morning air moves only in slow breaths, the sprawling branches of rhododendron ponticum unfold their pale pink blossoms against a thick canopy of deep green leaves. Each broad flower opens gradually under the gentle warmth of the sun, revealing a delicate arrangement of curved stamens that extend into the still atmosphere like slender fingers. Filtered sunlight trickles down through the high canopy overhead, casting soft patterns of light and shadow across the smooth petals, while illuminating the fine, velvety textures that line the inner throat of every blossom. Here, in the cool stillness of the forest glade, time seems to stretch out and slow its pace, measured only by the silent, steady shifting of golden light and the gradual unfolding of fresh corollas. The ambient quiet invites an effortless, restful pause, creating a tranquil sanctuary where the subtle microscopic architectures of plant life perform their timeless, essential tasks without any hurry or noise. Within the heart of these soft, rosy blossoms lies a remarkably elegant piece of botanical design, evolved to ensure that the continuation of life proceeds with the gentlest possible touch. Rather than scattering individual dust-like particles into the passing breeze, where they might drift aimlessly, the plant employs a far more cohesive method of transfer. Inside the pink blossoms of Rhododendron ponticum asterisk, golden pollen grains are bound together by microscopic threads of elastic vicin, allowing a landing bumblebee to pull out long, silk-like ribbons of pollen that softly cling to its coat. As the foraging insect alights lazily onto the broad lower petals, its quiet weight depresses the flower's natural support structures, just enough to bring its velvet coat into direct contact with these delicate, elastic strands. With each slow and deliberate movement of the visitor's legs and body, the vicin extends smoothly without snapping, drawing out shimmering ribbons of golden dust that drape gently across the bee's back like fine silk thread. It is a soft and efficient mechanism, ensuring that an ample, unbroken measure of pollen travels safely to the next blossom while preserving the flower's precious gifts. When the bumblebee eventually lifts off into the calm air on steady, rhythmic wings, the elastic vicin threads yield gently, releasing their golden payload to be carried smoothly across the meadow toward another waiting stigma. Behind it, the pink blossom sways gently before coming to rest once more in the dappled light, its stamens intact and ready for the quiet moments that lie ahead. Throughout the calm afternoon, as the daylight softens into a warm amber and long shadows stretch lazily across the mossy floor, these peaceful exchanges unfold in quiet harmony across the entire grove. The elegant, physical grace of the vicin thread serves as a gentle reminder of the extraordinary care woven into the smallest mechanics of nature, where flexibility and strength work in perfect balance to sustain the endless floral cycles. In this tranquil environment, each blossom rests easy in the fading light, fulfilled in its silent purpose as calm evening settles over the woods. In the quiet understory of mountain slopes and damp woodland clearings, early summer brings a delicate architecture into bloom. Beneath the cooling shade of broad-leafed canopies, clusters of mountain laurel unfold in soft shades of pale pink and porcelain white. To a casual observer walking along the mossy path, these flowers appear as serene, motionless ornaments resting upon dark evergreen boughs. Yet within each quiet cup lies a subtle and intricate engineering, refined across countless generations to align perfectly with the movements of foraging insects. The physics of the plant kingdom rarely relies on sudden force or constant expenditure of work. Instead, it often favors the accumulation of patient, potential energy held in complete stillness. Every curve of a petal and every gentle bend of a filament is calibrated to respond to the softest touch, turning an ordinary landing into a moment of seamless interaction. As afternoon shadows stretch long and cool across the forest floor, The woods hold millions of these tranquil, suspended mechanisms, each waiting patiently in the quiet shade for the gentle arrival of a traveling bee. When a foraging bee settles upon one of these open blossoms, the flower's quiet mechanics awaken in a moment of subtle movement. The bowl-shaped blossoms of the mountain laurel *Calmia latifolia hold 10 spring-loaded stamens pinned under tension inside tiny petal notches, releasing with a soft spring to gently brush golden pollen onto the velvety abdomen of a landing bee. This remarkable mechanism operates with effortless grace, driven entirely by elastic tension stored within the plant's own growing tissues. As the flower originally matures, its 10 slender filaments grow under physical strain, arching outward so that their pollen-bearing tips become locked into small, custom-formed pockets along the corolla walls. When a visiting bee explores the center of the bloom in search of sweet nectar, its legs or mouth parts nudge the primed filaments, dislodging them from their shallow resting places. In an instant, the stored tension converts into movement, snapping the anthers inward with a delicate flick that dusts the visitor without alarming it. It is a fleeting, peaceful collision that ensures the transfer of pollen, allowing the flower to achieve its vital work through physics alone. This gentle release of physical tension occurs time and again throughout the woodland blossom season, reflecting a profound harmony between plant form and insect behavior. Once their stored energy is released, the slender stamens curve softly toward the central style, resting peacefully in their relaxed positions after fulfilling their brief role in the life of the plant. The bee, now bearing a fine dusting of microfine golden grains, drifts away through the quiet forest air to visit neighboring blossoms across the ridge, carrying the subtle thread of floral continuity from one bloom to the next. Across the shaded landscape, countless flowers perform these microscopic, passive movements, demonstrating how nature uses rest, elastic tension, and quiet release to sustain the wider forest ecosystem without waste or struggle. As evening falls and the ambient temperature slowly drops, the mountain laurel blossoms rest undisturbed in the gathering dusk, their delicate mechanisms spent, entering a peaceful state of nocturnal calm beneath the soft canopy of leaves. As dusk begins to settle over quiet fields, nature reveals a silent world of intricate mechanics, working with astonishing grace and restful precision. In the peaceful summer of 1793, botanist Christian Konrad Sprengel walked along the tranquil paths of Spandau, Germany, observing the calm rhythms of plant life. In 1793, botanist Christian Konrad Sprengel described the triplever mechanism of meadow clary *Salvia pratensis in Spandau, Germany, where a sipping bee gently nudges a sterile appendage, causing 2 stamens to pivot down like tiny wooden balance beams and leave a whisper of pollen across its back. There is no rush in this delicate exchange, only a slow, and rhythmic choreography honed across ages of quiet coexistence between plant and pollinator. The blossom does not force its gift upon the passing traveler, but rather welcomes it with a mechanical poise so fine that it feels almost like a deliberate, peaceful embrace. As the bee sips its sweet reward, the wooden balance beams return gently to their original resting stance, waiting patiently in the soft ambient air for the next visitor to arrive. The traveler carries this dusted golden reward onward, moving lazily from blossom to blossom, while the late afternoon light begins to soften across the tranquil landscape. Far across the sea, in the quiet, sunlit expanses of open grasslands, another remarkably gentle motion unfolds within the vibrant blooms of the prickly pear cactus, Opuntia polyacantha. When a foraging bee gently touches the inner stamens of the prickly pear cactus, Opuntia polyacantha, the dozens of golden filaments curl slowly inward over 3 to 5 seconds, wrapping softly around the insect to coat it in pollen. Like a warm hand closing in quiet slow motion, the delicate threads envelop the bee in a tender, velvety touch before relaxing once more into their wide, open posture. This subtle thigmonastic movement occurs with a deliberate tranquility, ensuring that every contact becomes a fruitful connection without ever alarming or disturbing the steady rhythm of the gathering pollinator. After receiving this quiet coating of fine dust, the insect drifts effortlessly away into the warm evening breeze, leaving the blossom to reset its golden array under the vast expanse of sky. These subtle, responsive movements highlight the peaceful intelligence embedded throughout the plant kingdom, where every pivot, lever, and curling filament is calibrated for quiet efficiency and harmony. Flowers do not move with haste or jarring suddenness, but with a patient grace that mirrors the gradual turning of the earth and the slow descent of evening. Whether through the balanced levers of a European meadow clary or the sensitive, wrapping threads of a desert cactus, nature has designed mechanical adaptations that operate in soft whispers rather than loud demands. As the sun dips lower below the horizon and the evening breeze settles into a calm, soothing murmur, these floral structures hold their quiet positions, resting in total harmony with the surrounding world. The air cools, the long shadows stretch across the grass, and the timeless cycles of growth and pollination rest for the night, inviting a deep, soothing sense of stillness, comfort, and peace to fall upon all living things. Across the quiet, sun-dappled landscapes of the world, plants have spent millions of years refining mechanisms of exquisite structural balance, responding to the gentlest interactions with passing life. Unlike the rapid movements found elsewhere in nature, the mechanical adaptations of many flowering species operate with a calm, deliberate patience. They wait in silent anticipation amidst the surrounding foliage, engineered to react only when a precise weight or subtle touch alights upon their petals. These restful structures do not require grand expenditures of energy. Instead, they rely on the fundamental forces of gravity and balance, converting a creature's brief moment of rest into a seamless act of continuation. As evening settles over coastal ridges and cool ocean breezes drift softly through the sun-bleached leaves, the floral architecture resting in the serene twilight reveals how seamlessly living form can blend with physical law. In the coastal valleys of South Africa, the bird of paradise flower, Strelitzia regini, uses the subtle weight of a perching sunbird to depress its blue floral sheath, gently exposing hidden stamens that lightly dust the bird's feet with pollen. This striking perennial conceals its inner reproductive organs within a pair of specialized, arrow-shaped blue petals fused into a rigid perch. When a small sunbird approaches in search of sweet nectar stored deep within the blossom's base, it lands directly upon this narrow blue landing platform. As the bird settles onto the structure, its downward mass acts as a delicate natural lever, depressing the protective sheath in a smooth, continuous movement. Beneath this shielding cover, the hidden stamens emerge into the open air, just enough to contact the underside of the bird's perching feet, leaving behind a fine dusting of pale golden pollen grains without alarming the visiting bird. This mechanical design ensures that pollen is transferred with remarkable efficiency, while shielding the flower's reproductive material from wind, rain, and lighter insects that lack the weight required to trigger the lever. Small, delicate insects may rest upon the bright orange sepals without ever displacing the protective blue sheath, leaving the sweet nectar untouched until an avian pollinator of appropriate size arrives. The relationship between flower and sunbird is thus governed by a quiet physical threshold where form and mass meet in perfect calibration. Neither creature nor plant exerts unnecessary effort. The flower offers a supportive roost and rich nourishment, while the bird acts as a precise courier, bearing the golden pollen dust to the next waiting bloom across the misty coastal hillside. Once the sunbird finishes sipping the nectar and gracefully takes to the air, the flexible sheath slowly relaxes, returning seamlessly to its original position over the stamens to protect the remaining pollen. The sunbird glides quietly across the soft valley air to a neighboring Strelitzia asterisk, where its landing once more depresses the blue petals, allowing the receptive stigma to press gently against the bird's pollen-dusted feet and complete the transfer. In this calm, recurring ritual, generations of flowers and birds remain linked in quiet, natural harmony. As twilight deepens into night and the sunbirds retreat to their nests, the blossoms stand serene under the emerging stars, their subtle mechanical perches resting in peaceful, silent readiness for the coming dawn. Across the quiet tropics, where warm moisture lingers in the morning mist and soft breezes rustle through dense green foliage, certain flowers hold their inner secrets with remarkable care. Among these patient blossoms is asterisk vanilla planifolia asterisk, an elegant orchid vine that winds gracefully around the mossy trunks of supporting trees, presenting pale green and soft yellow blossoms that open for only a few fleeting hours in the tranquility of early morning. For many decades after European botanists carried the trailing vine from its native soils in Mexico across wide ocean currents, the orchid flourished in lush glasshouses and tropical botanical gardens, expanding its lush tendrils, yet yielding no fruit. Its delicate yellow flowers would unfurl at dawn, wait peacefully in the humid shade, and wither by late afternoon without ever setting a single fragrant seed pod. The plant's natural partners, tiny, specialized Melipona stingless bees, native only to Mesoamerican forests, were absent in these far-flung regions, and the flower's subtle inner architecture posed a quiet, enduring puzzle. Deep inside the throat of each blossom lay a tiny physical barrier known as the rostellum, a gentle structural flap designed by nature to keep the male and female organs separated, ensuring that, without a deliberate bridge between the anther and the stigma, the pollen remained forever untouched and the fruit unformed. It was in this tranquil atmosphere of daily observation and quiet curiosity that a young boy unlocked the orchid's delicate secret. In 1841, on the island of Reunion, 12-year-old Edmund Albius devised a gentle manual pollination technique for asterisk vanilla planifolia, using a thin bamboo splint to lift the flower's delicate rostellum flap and press the pollen against the stigma with his thumb. This remarkably simple, tender gesture required no force or elaborate mechanical apparatus, needing only a steady hand, a patient eye, and a soft, intuitive understanding of the blossom's hidden geometry. Working quietly among the shaded morning vines before the tropical sun could warm the air and cause the ephemeral petals to close, Edmund moved from stem to stem with effortless, rhythmic precision. By gently lifting the thin protective flap within the flower's core and pressing the sticky golden pollen into its receptive bed, he fulfilled the role once played solely by wild insects, transforming the global story of vanilla into a peaceful art form dependent entirely upon human care and quiet focus. This soft, deliberate interaction between human mindfulness and plant biology remains one of the most serene examples of agricultural practice. Even today, every single vanilla bean that matures months later into a dark, aromatic pod is the result of an individual, gentle touch performed during those brief morning hours when the flower first awakens. The process cannot be rushed by industrial machinery or hurried by modern demands. It remains fundamentally bound to the same quiet presence, the same rhythmic patience, and the same profound respect for natural cycles that Edmund brought to the gardens of Reunion nearly 2 centuries ago. as twilight falls over the orchid plantations, and the leaves rest quietly under the fading sky. The story of the vanilla flower offers a soothing reminder of how profound discoveries often arise not from noise or ambition, but from quiet moments of attentive observation, where a tender touch allows nature to complete its timeless cycle in complete peace. Where terrestrial blossoms depend upon the transient visit of breezes or winged visitors, water plants invoke a quieter, fluid choreography that relies on the subtle physics of liquid boundaries. Upon the tranquil mirror of still freshwater ponds, a delicate interplay of surface tension and natural buoyancy guides the continuation of life beneath the open sky. On still freshwater ponds, female *Vallisneria spiralis flowers extend upward on coiled stems to rest on the water's surface tension, creating tiny surface dimples into which buoyant, unattached male blossoms naturally drift like miniature boats. Having detached from their underwater clusters far below, these tiny male flowers rise gently to the top and float freely, wandering across the mirror-like expanse without roots or tethers. Guided by the microscopic depressions carved by the floating female blooms, they glide smoothly across the surface, drawn inward by the quiet mechanics of capillary attraction, until they meet in soft contact. It is a process entirely devoid of urgency, governed by the peaceful laws of liquid physics and the slow, rhythmic stillness of undisturbed water resting under a quiet evening sky. Moving from the quiet shallows of inland ponds toward the vast, salt-scented horizons of estuarine bays and sheltered ocean inlets, aquatic flora adapt to the heavier density and constant cadence of marine environments. In submerged coastal meadows, eelgrass, Zostera marina *, releases thread-like pollen grains measuring up to 2 millimeters long that match the exact buoyancy of seawater, drifting silently through low tides until their delicate strands wrap around feathery stigmas. Unlike terrestrial pollen designed to float upon the air, these extended marine strands possess a density so perfectly tuned to the ocean that they remain weightless in the brine, neither sinking into the muddy seabed nor floating upward toward the sunlit surface. Suspended in total balance within the clear salt water, they glide along the quiet undercurrents of the meadow, tumbling gently through the submerged foliage until their long, flexible bodies catch upon the waiting stigmas. In these submerged green pastures, pollination proceeds without sound or struggle, reliant only upon the soft sway of the tides and the patient drift of deep ocean currents. This quiet hydrophilous pollination demonstrates the exquisite alignment between living forms and the physical laws of the natural world, where movement requires no exertion beyond surrendering to the natural flow of water. Whether on the motionless surface of a secluded pond or within the cool depths of a tidal bay, these underwater and surface mechanics operate with a serene, effortless precision. the unhurried journey of a floating blossom navigating a surface dimple, or a delicate filament of pollen weaving through sea ribbon leaves, mirrors the quiet rhythm of restful slumber itself. As twilight fades and evening stillness settles over pond margins and marine estuaries, the waters grow dark, glassy, and completely calm, reflecting the quiet stars overhead. Beneath that smooth liquid mirror, the day's gentle work draws to a peaceful close, leaving the aquatic flora resting securely within the slow, cradling motion of the silent, slumbering water. Across the damp, low-lying wet meadows of northern and central Europe, where cool morning mist gathers softly in the hollows and pale light filters through the misty air, nature moves to a deeply unhurried rhythm. Here, deeply embedded within spongy peat mosses, marsh marigolds, and tall, slender sedges, delicate white blossoms awaken under the quiet autumn sky. The soil beneath them remains perpetually moist, feeding subterranean roots that draw steady, restorative nutrition from the rich earth, while a cool, gentle breeze whispers through the damp grasses. In these peaceful and secluded habitats, floral life does not rush toward completion, nor does it display all of its hidden treasures at once. Instead, each botanical element unfolds through a deliberate, measured schedule, attuned perfectly to the gentle passage of hours, days, and changing seasons. The surrounding air carries the crisp, clean fragrance of damp earth and slow-moving water, creating a restful sanctuary where life proceeds with effortless patience, quiet dignity, and complete serenity. Among these tranquil marshy landscapes, the grass of Parnassus, known scientifically as Parnassia palustris asterisk, reveals one of the most serene and meticulous choreographies found anywhere in the natural world. Its solitary, star-like flower rests gracefully atop a smooth, slender green stem, displaying 5 porcelain-white petals that appear almost translucent against the soft daylight, finely traced with subtle, luminous emerald veins. At the very heart of this pristine blossom, a quiet and orderly rhythm governs the distribution of life, rather than shedding all of its precious pollen in a single abrupt or wasteful moment. The flower orchestrates a remarkably slow, measured dance spanning 5 distinct days. In damp European wet meadows, the grass of Parnassus asterisk Parnassia palustris presents its golden pollen through a quiet 5-day sequence, extending a single stamen to the blossom's center each morning for 24 hours before it arches gently back to let the next advance. This daily movement proceeds with silent, mathematical precision, as each stamen takes its solitary turn at the center of the flower to offer its golden grains to passing pollinators before bowing gracefully into the shadow of the outer petals. This staggered botanical cadence serves a profound and elegant purpose within the gentle economy of the meadow. By releasing its pollen incrementally across 5 successive days, The plant guarantees that its reproductive offerings are protected against unpredictable weather. Whether bright sun or passing afternoon showers sweep across the landscape, visiting solitary bees, hoverflies, and small beetles, drawn by the flower's delicate visual beauty and subtle scent, discover a fresh, untouched supply of pollen on every visit, which promotes effective cross-pollination among neighboring plants without ever overcrowding the blossom's delicate central stigma. Only after all 5 stamens have completed their full 24-hour vigil and arched softly back into place does the central stigma fully mature, opening itself to receive pollen carried from another distant bloom. Through this harmonious succession, self-pollination is naturally prevented, and genetic diversity is gently sustained across generations. It is an intricate system built not upon urgency or aggressive competition, but upon balance, patient timing, and quiet natural cooperation. As twilight softly settles over the meadow once more, the blossom remains peaceful in the cool evening air, its quiet cycle continuing effortlessly according to the slow, calming clock of nature. As the soft, silvery veil of twilight gently settles over the garden, the natural world enters a serene transition into the quiet hours of night. The evening air grows gradually cooler, carrying with it the subtle, grounding moisture of early dew, while the daytime melodies of songbirds softly fade into the quiet, rhythmic hum of nocturnal life. Beneath the darkening sky, flowers do not simply close their petals in sleep. Rather, many species initiate an extraordinarily deliberate and calm sequence of scent, posture, and form. These nocturnal bloomers have adapted over thousands of generations to send quiet invitations into the cooling darkness, relying on pale, luminous petals that easily catch the subtle reflection of starlight and moonbeams, alongside rich, lingering fragrances that drift through the still air. This twilight shift marks a peaceful passing of the guard between day and night, illustrating the intricate, perfectly balanced harmony between plant life and the specialized creatures that wander beneath the moon. Among these botanical timekeepers, few demonstrate this dynamic sequence as beautifully as the Rangoon creeper, known scientifically as Combretum indicum. Over 3 consecutive days, the blossoms of the Rangoon creeper transform from fragrant white petals held horizontally at dusk for hawkmoths into soft pink, then finally droop downward into deep crimson to welcome daytime butterflies. This subtle evolution in color, scent, and spatial orientation is a masterclass in quiet biological efficiency and visual communication. On that first night, the fresh white petals stand proudly outward, acting as bright beacons in the dim light while diffusing their sweet, inviting fragrance into the evening breeze to attract wide-eyed hawkmoths hovering softly on silent wings. As day dawns, the flower gently begins its transition, softening into a delicate rose hue, before ultimately relaxing its posture on the third day to hang downward in a deep autumnal crimson. In doing so, the vine gracefully signals to passing insects which blossoms hold fresh rewards, ensuring that visiting pollinators can navigate the vine with ease and absolute certainty. This continuous chromatic symphony provides a serene example of how plants conserve their precious energy while maintaining rich, vibrant ecological relationships across different times of day. Rather than shedding petals prematurely or continuing to produce nectar when it is no longer required, the vine relies on subtle shifts in pigment and physical posture to speak silently to the surrounding world. The crimson blooms continue to offer visual warmth to the garden landscape while guiding daytime butterflies, leaving the newly opened, starry white blossoms clear and unburdened for the night-flying moths that return with the dusk. As darkness settles fully over the quiet garden and the older crimson petals rest gently in the cool shadows, fresh white blooms begin their own quiet first evening under the sky. The slow, predictable rhythm of these floral cycles mirrors the calm, steady heartbeat of the earth, inviting us to slow our thoughts, breathe deeply, and rest in the quiet beauty of a world that moves with such gentle, timeless purpose. As late summer turns its soft face toward the crisp quiet of autumn, the meadow transforms into a sanctuary of measured movements and subtle architecture. The cooling evening air carries the faint, comforting scent of damp earth and fallen foliage, settling gently over the landscape like a soft blanket. Across these quiet stretches of land, native flora have evolved remarkable ways to shelter their vital reproductive treasures against the unpredictable autumn elements. While many wildflowers stretch their petals wide to greet the morning sun, others choose a more reserved path of protection. They construct miniature, weatherproof vaults that safeguard their rich nectar and delicate pollen grains from sudden rainstorms and heavy evening dews. In this calm, deliberate world, every curve of a leaf and fold of a petal serves a tranquil purpose, ensuring that the ancient cycle of pollination proceeds without disruption. Even as the seasonal light begins to softly dim across the silent fields, among these quiet botanical wonders is a plant that keeps its sweetest secrets tucked safely away from the casual observer. The deep indigo petals of the bottle gentian *gentiana clausa remain permanently closed into a tight, teardrop-shaped bud, protecting its nectar from rain while requiring robust bumblebees to gently push open the pleated tip and slip entirely inside to feed, where other blossoms unfurl broadly to welcome any passing insect. This specialized flower forms a private, velvety chamber of rich cobalt and violet folds. The tight seal acts as a natural umbrella, keeping the inner pool of liquid nourishment concentrated and perfectly dry regardless of how heavily the evening mist or autumn showers settle upon the meadow. To gain entry into this peaceful haven, an insect cannot simply land upon upon an open platform. It must possess the unique physical strength, weight, and persistence needed to part the delicate, overlapping pleats at the top of the stem. Watching this gentle interaction unfolds like a slow, rhythmic lullaby performed in the fading light of dusk. A heavy, dust-draped bumblebee approaches the indigo bell, landing securely upon the firm outer structure of the bloom. With a slow and practiced effort, the bee presses its head against the pleated seam, nudging forward until the resilient petals yield just enough for its furry body to slip completely inside. For a brief moment, the blossom sways quietly on its slender stem, concealing its visitor in total stillness, save for a muffled, rhythmic hum echoing from deep within the midnight blue sanctuary. As the bee feeds in the dark interior, its body brushes softly against the hidden stamens, gathering microscopic golden grains of pollen on its fur. When finished, the bumblebee backs out smoothly, allowing the pleated tip to spring softly back into place. Once the insect departs into the twilight, the bottle gentian stands completely intact, its interior remaining pure, warm, and undisturbed by the cold night air. This elegant partnership between plant and bee illustrates the quiet harmony that governs the natural world, where strength and delicacy work together in silent balance. As darkness deepens across the meadow, the closed buds hold their sweet reserves in safety, awaiting the return of tomorrow's gentle visitors. The surrounding grasses rustle softly in the night breeze, carrying the quiet rhythm of the earth into a peaceful state of rest, where every living thing slumbers in harmony with the gentle mechanics of the seasons. As dusk softly settles over quiet fields and woodland edges, a subtle transformation begins among the evening blossoms. The fading warmth of sunlight gives way to the cool, damp breath of night, inviting a peaceful shift in the rhythm of the living world. While daytime pollinators rest beneath leaves and within sheltered hollows, a different group of gentle creatures awakens to meet the flowers of the dark. These nocturnal blossoms do not rely on bright, vivid hues to attract their visitors. Instead, they unfurl with pale petals that catch the faint silver glow of moonlight, casting delicate, wafting scents into the still night air. It is a quiet, timeless choreography, refined over countless generations, where timing, form, and fragrance align in complete harmony with the slow movements of twilight flyers. Along quiet limestone slopes and grassy meadows, the Nottingham catchfly, Silene nutans, engages in a remarkably patient three-night dance of revelation. Over 3 consecutive summer evenings, the Nottingham catchfly, Silene nutans, unfurls its pale petals and releases a soft hyacinth fragrance, revealing a new set of stamens on the first 2 nights, and its 3 female styles on the third to welcome night-flying moths. On that initial evening, 5 delicate stamens extend outward into the dusk, offering their fine pollen to passing wings. As dawn approaches, the petals roll back inward to protect their delicate inner workings from the daytime sun, only to loosen once more when twilight returns. On the second evening, another set of stamens emerges to double the opportunity for pollen dispersal. Finally, on the third night, when the pollen from its own blossoms has largely spent itself, the three slender styles unfurl, ready to receive pollen carried on the velvety wings of nocturnal visitors. This slow, deliberate sequence prevents self-pollination, ensuring that genetic diversity flows gently through the species beneath the quiet stars. This intimate interdependence between flower structure and insect form has long fascinated those who observe the natural world with quiet patience. In 1862, naturalist Charles Darwin studied the Madagascar comet orchid, Angricum sesquipedale, and predicted the existence of an undiscovered nocturnal hawk moth with a 30-centimeter long proboscis, capable of reaching the sweet nectar hidden deep within the orchid's slender spur. At the time, many naturalists doubted that such a creature could exist, as no moth with a nectar-drinking tube of such extraordinary length had ever been observed. Yet Darwin recognized that the orchid's deep, translucent spur, extending tens of centimeters beneath the star-shaped white flower, served no biological purpose unless a pollinator possessed the exact mechanical key to unlock its hidden reward. Decades after his calm prediction, the hawkmoth Xanthopan morganae predicta was indeed discovered in the lush forests of Madagascar, its long proboscis perfectly matching the floral architecture Darwin had examined so closely years before. In these quiet nocturnal partnerships, we see the profound elegance of natural design working without haste or fanfare. Each long spur, each unfolding petal, and each gentle release of scent is calibrated to the precise needs of life moving through the darkness. As the night deepens, these gentle mechanisms continue their silent work, uniting plant and pollinator in an unbroken, peaceful cycle that quietly sustains the world while it slumbers. As twilight yields completely to the humid stillness of the tropical evening, the high canopy transitions into a peaceful realm governed by subtle whispers, unseen breezes, and soft, rhythmic vibrations. In the deep shadows beneath the upper layers of foliage, where the last fading light of dusk leaves no remaining trace of visual color, the forest turns to alternate harmonies to carry on its quiet work of renewal and connection. Daytime blossoms, which relied so heavily on the vivid spectrum of sunlight to attract bees, hummingbirds, and colorful butterflies, slowly fold their petals or rest in silent patience until the morning light returns. In their place, nocturnal flora gently awaken, releasing faint, honeyed scents carried on the cool, moisture-rich currents of night air, and offering physical structures specifically tailored for the darkness. The forest at night is never truly dormant. Rather, it is filled with soft, unseen movements, the slow rustle of damp leaves, the rich aroma of rain-soaked earth, and the delicate, invisible sonar pulses emitted by winged creatures, navigating carefully through the dense leafy labyrinth above. Deep in the Cuban rainforest, the climbing vine *Markgravia evenea grows, dish-shaped concave leaves directly above its floral clusters, functioning as acoustic mirrors that reflect the echolocation clicks of passing nectar bats to guide them softly through the dark canopy. Positioned like small, smooth saucers just above the suspended clusters of downward hanging flowers, these specialized leaves serve an extraordinary acoustic purpose in the pitch-black environment. While typical foliage scatters high-frequency sound waves unpredictably in every direction, the precise parabolic curvature of these concave leaves gathers and concentrates the bat's ultrasonic signals, bouncing them back with remarkable clarity. To a nectar bat searching through the dark forest, these returned echoes sound entirely distinct from the surrounding background clutter of standard leaves, creating an unmistakable acoustic beacon that shines like a quiet lighthouse of sound. The bat follows these soft audio reflections directly to the center of the vine's rich nectar, hovering briefly in place while transferring pollen before gliding peacefully onward through the shadowy trees. This peaceful interplay between sound waves and leaf structure illustrates the quiet elegance of natural design, where life flourishes not through competition or force, but through a gentle tuning to the surrounding environment. The vine does not need to glow in the darkness or rely on bright visual cues. Instead, it shapes the physical echoes of the night itself, meeting the bat's sensory perception with complete, effortless harmony. As these small nocturnal pollinators move patiently from one acoustic mirror to another across the upper canopy, the ancient cycle of floral reproduction unfolds in a smooth, uninterrupted rhythm beneath the stars. Each subtle click sent into the quiet air returns as a clear and reassuring invitation, ensuring that pollen is transported gently across the sleeping forest without breaking the deep serenity of the tropical night. In this nocturnal sanctuary, every element exists in calm equilibrium, resting comfortably within the slow, steady, and restorative pulse of the natural world. As twilight settles softly over the vast, arid scrublands of the American Southwest, the long, intense heat of the desert day slowly recedes, giving way to a cool and deeply restorative nocturnal stillness. Across the wide and shadowy expanses of stone and dry soil, the elegant stalks of Yucca filamentosa stand like quiet guardians against the deepening dusk, their pale, bell-shaped blossoms unfolding with gentle grace into the night air. A subtle, sweet perfume drifts from the cream-colored petals, floating on the soft evening breeze that wanders through the canyon floor. Overhead, the sky transitions into a velvety indigo, dotted with the quiet light of countless distant stars. In this calm and unhurried environment, far removed from the bright energy of the midday sun, the natural world settles into a serene rhythm, inviting a profound sense of restful quietude over the sleeping desert landscape. Within the sheltered, ivory interior of these nodding flowers, a delicate and remarkable creature begins her nightly ritual, moving with slow and deliberate precision. In the arid scrublands of the American Southwest, the female yucca moth, Tegaticula yuccacella, uses specialized mouthparts to compact golden pollen into a tiny sphere, carrying it to a asterisk yucca filamentosa flower, where she carefully packs it into the cup-shaped stigma to ensure future seed growth. Visiting the pollen-bearing anthers of a freshly opened bloom, she relies on her evolutionary adaptations, appendages specially formed over millions of generations, to gather the fine, sticky grains of gold. Rather than consuming the pollen or allowing it to disperse aimlessly on the wind, she meticulously molds it into a smooth, compact orb beneath her chin, holding her precious burden secure as she prepares to journey to a neighboring plant. Drifting effortlessly through the cool, fragrant night, the moth alights upon another yucca blossom, resting peacefully in the moonlight. She moves gently toward the center of the flower, locating the small depression of the cup-shaped stigma with extraordinary care. With patient, tender movements, she presses the compacted pollen sphere deep into the receptive cavity, completing an act of pollination that is essential for the plant's reproduction. In exchange for this essential service, she lays a small number of her own eggs within the flower's sheltered ovary. As the pollinated blossom begins its slow transition towards seed development, it will yield more than enough nourishment for her future larvae, while leaving an abundance of intact seeds behind, ensuring that future stands of yucca will continue to thrive across the desert expanse. There is an enduring beauty in this quiet, nocturnal balance, where two distinct species rely entirely upon one another in order to flourish. As the moth finishes her work and glides softly into the shadowy canopy of the scrubland, the yucca blossom cradles the newly deposited pollen, quietly initiating the invisible process of fertilization beneath the starlit sky. The desert rests in total tranquility, wrapped in the cool embrace of the night. In these peaceful hours, the gentle mechanics of pollination operate without sound or hurry, serving as a comforting reminder of the silent, reliable cycles that sustain life across the earth, guiding every blossom and creature through the steady, unfolding rhythm of time. As twilight deepens across the quiet corners of the natural world, a subtle warmth begins to stir within certain nocturnal blossoms, inviting tiny creatures into safe and peaceful sanctuaries. Beyond the simple, visible beauty of opening petals lies a remarkable microclimate, where plants generate their own soft heat to welcome nocturnal pollinators seeking shelter from the cool evening air. In these dark hours, the slow and rhythmic cycles of floral life perform an intricate dance of hospitality and mutual care. Through delicate chemical transformations carried out in complete quiet, flowers become tiny, radiant lanterns of heat and scent, offering gentle rest to the insects that wander through the shadowy dusk. This evening warmth creates a soothing haven where life pauses, rested and secure beneath the night sky. Far to the south, in the quiet oxbow lakes of the Amazon basin, the Victoria amazonica lily opens white at dusk, metabolizing stored starches to warm its inner chamber up to 10 degrees Celsius above the night air, while releasing a gentle, fruit-scented heat. This extraordinary thermogenic effort creates a welcoming, highly fragrant refuge amid the dark. Still water, drawing tiny scarab beetles deep into the heart of the expanding flower. Encased within the velvety inner chamber, the beetles rest safely in the soothing, steady warmth throughout the dark hours, completely untroubled by night predators or the cool river breeze drifting across the water. As night slowly turns toward dawn, the flower quietly closes its thick petals, gently retaining its small guests, while it gradually transitions from pristine white to a soft, warm shade of pink. When the blossom opens once more on the following evening, it liberates the rested beetles, who carry a delicate coating of pollen with them across the calm water to neighboring lilies, ensuring the continuation of the ancient aquatic floral cycle. A similar rhythm of evening shelter unfolds across the temperate highlands of North America, where ancient woodlands host their own quiet traditions of floral warmth. During quiet spring evenings in the Appalachian forest, the thick maroon petals of the Carolina sweet shrub, Calicanthus floridus, gently fold inward to wrap tiny sap beetles in a warm, strawberry-scented sanctuary until dawn, when the blossom unfolds to let them drift away, covered in pollen. The dense, wine-colored petals create a cozy, protective envelope, shielding the tiny beetles from the damp evening moisture and cool drafts that settle across the mossy forest floor. Resting deeply within this aromatic chamber, the insects remain safe and nourished through the still hours of darkness, bathed in the rich, soothing fragrance of ripe fruit. When the early morning sunlight finally filters through the high forest canopy, the petals loosen their soft hold, releasing their nocturnal visitors to catch the morning breeze and carry the gift of life across the woodland floor. These nocturnal sanctuaries reflect the quiet grace inherent in the mechanics of pollination, where life sustains life not through effort or force, but through warmth, comfort, and peaceful harmony. The delicate temperature differences maintained within these velvet petals remind us of the quiet care built into the fabric of the living world. As the night deepens and the woodland air turns still, these blossoms hold their sleepy travelers safe until dawn, keeping watch under the starlit sky as the endless cycles of nature gently continue. As twilight deepens over quiet waters, a soothing stillness descends upon the wetlands, wrapping the natural world in soft shades of indigo, slate, and mist. The gentle ripple of water slowing against smooth lotus stems marks the peaceful transition into night. An hour when the bustling activity of daylight yields to a quieter, far more restful rhythm. Above the glassy surface of the pond, broad green leaves rest motionless, holding tiny beads of dew that shimmer softly under the pale glow of the moon. In this tranquil realm, the floral world does not merely drift into sleep. It enters a delicate and hidden cycle of nocturnal stewardship. While many blossoms close their petals tightly to guard against the damp night air, others begin a subtle, remarkable transformation designed to shelter the small, weary creatures of the marsh. The surrounding air grows cool and crisp, yet amidst the vast, calm expanse of water, pockets of gentle vitality persist, created by plants that turn their internal energies toward generating solace and enduring warmth in the dark. Among these evening guardians, none is more steady or welcoming than the great lotus resting quietly in its aquatic cradle. Across quiet Asian wetlands, the sacred lotus, Nelumbo nucifera, maintains its central floral chamber at a constant 32 degrees Celsius for up to 4 consecutive nights by burning stored starches, offering a warm, fragrant sanctuary for sleeping beetles. This precise thermogenic process operates with remarkable constancy, unaffected by the ambient chill of the midnight air or the soft breezes drifting across the marshy waters. As the plant gently converts its rich, accumulated reserves into steady thermal energy, it releases soft, sweet scents that diffuse slowly through the dusk. Drawn by both the comforting temperature and the inviting aroma, small beetles crawl deep within the protective, overlapping layers of petals, finding a safe haven where they can rest undisturbed throughout the long night. Enclosed within this living hearth, the insects are insulated from cold drafts, conserving their own energy while inadvertently brushing against pollen-laden anthers, ensuring that when dawn arrives, the cycle of life will continue in seamless, quiet harmony. This quiet act of hospitality highlights the deep interconnections that govern floral cycles and their insect companions. The expenditure of stored starches is not a rapid or frantic burst of heat, but rather a slow, deliberate metabolic pulse, carefully regulated to sustain a peaceful equilibrium through the coolest hours before morning. Within the lotus chamber, the air remains pleasantly humid and still, creating an ideal microclimate where life can pause and regenerate in complete safety. As the night wears on, the rhythmic burning of starches continues softly, like a quiet fireplace suspended above the dark waters. The beetles, lulled by the steady warmth and rich scent, remain slumbering peacefully until the first light of dawn begins to paint the eastern sky. When the rising sun finally warms the outer atmosphere, the lotus gently opens its petals once more, releasing its rested guests into the cool new day. In this serene exchange, nature reveals its capacity for gentle care, demonstrating how even the simple maintenance of warmth can foster life and quiet rest across the interconnected tapestry of the natural world. As the evening air settles into a deep and motionless hush, the botanical world turns toward a different rhythm altogether, governed not by the glare of the midday sun, but by the subtle cool of twilight and shadow. Where daytime blooms depend on bright hues and open sunlight to attract buzzing visitors, nocturnal flowers rely upon soft luminescence, pale textures, and sweeping scents to communicate across the quiet dark. In these still hours, atmospheric humidity lingers near the earth, carrying fragrant molecules farther across gentle breezes without the scattering heat of the day. Leaves relax their tension, branches rest in quiet alignment, and the steady movement of sap slows down as the landscape prepares for rest. For certain plants, this nightly stillness is not merely a pause between daylight hours, but the singular moment toward which an entire year of slow, patient growth has been softly building, awaiting the precise alignment of temperature, moisture, and starlight. Among these subtle marvels, few occurrences display such silent devotion as the brief opening of desert blossoms, tailored specifically for the quiet hours of night. The night-blooming cactus, *Epiphyllum oxypetalum, unfurls its 20-centimeter wide ivory petals for only a single midnight window each year, releasing a soothing vanilla jasmine fragrance into the dark air before quietly closing forever at dawn. This extraordinary, transient bloom unfolds over several quiet hours, opening petal by petal with delicate precision, while the surrounding world reposes in sleep. Its broad white petals catch whatever faint moonlight filters through the canopy, creating an inviting beacon for nocturnal pollinators such as sphinx moths and nectar-seeking bats traveling across the cool air. The rich, calming scent floats gently through the stillness, guiding these night flyers with exquisite clarity over considerable distances. Yet there is no haste in this ephemeral display. Every stage of the expansion occurs with profound tranquility, as if the plant fully understands the quiet elegance of its singular midnight appointment. Within the delicate structure of the blossom, the mechanisms of pollination operate with peaceful efficiency. The soft yellow stamens hold their pollen ready for the gentlest touch of a passing wing, requiring no harsh winds or dramatic movements to complete their delicate task. As night creatures move softly from flower to flower, guided by the soothing fragrance drifting through the darkness, tiny grains of pollen are transferred with remarkable ease. This quiet interaction between plant and pollinator represents millions of years of gentle coevolution, an intricate dance conducted entirely in the soft sanctuary of the dark. As the first pale hints of dawn begin to touch the eastern horizon, the brief miracle completes its cycle with the same quiet grace with which it began. The ivory petals lose their gentle tension, folding back over the central reproductive heart as the cool night air gives way to morning warmth. Though its active display lasts only a few short hours, the energy gathered throughout the previous season has fulfilled its purpose, transferring pollen gently onward into the unfolding narrative of life. The surrounding garden returns to its customary stillness, retaining only the faint memory of vanilla and jasmine resting soft upon the awakening leaves. All around, roots continue to absorb steady nourishment from the cool, damp soil. Stems hold their silent poise, and the peaceful rhythm of nature rests until the turning of the seasons brings forth another quiet bloom. As twilight deepens and the evening air grows cool, a quiet stillness settles over the green spaces of the world. Long after the bright warmth of the afternoon sun has drifted beyond the horizon, plants continue their silent, rhythmic choreography with remarkable grace. It is easy to imagine that flowers and leaves simply react to the presence or absence of daylight, opening when greeted by the morning beam and closing when shadow returns. Yet the leaves and petals of many species move according to a deeper, innate sense of time, an unspoken awareness of day and night that beats softly within every cell. As dusk approaches, delicate foliage begins to droop softly, and blossoms pull their petals inward like a soft blanket drawn over sleeping shoulders. This evening rest is not merely a passive response to the fading light, but a timed sequence of micro-movements designed to safeguard sensitive pollen from the damp chill of night, to conserve precious moisture, and to preserve energy for the coming day. In this quiet transition, the botanical world enters a state of serene rest, perfectly aligned with the steady rotation of the earth. This profound ability of plants to keep time from within was first brought to light through a simple, elegant experiment conducted nearly 3 centuries ago. In 1729, French astronomer Jean-Jacques Dortus de Marin placed an asterisk mimosa pudica plant inside a dark, light-proof cabinet in Paris, and discovered that its feathered leaves still folded softly every evening at dusk, offering the first proof of an internal plant clock. Enclosed within total darkness, far removed from the shifting sky and the gentle rise and fall of ambient temperature, the sensitive plant continued to honor its nightly ritual with unfailing regularity. Each morning in the pitch-black space, its tiny leaflets would expand to welcome a dawn it could not see, and each evening they would gently drop back into rest. De Marin's observation revealed that the rhythms of life are written deep within the living organism itself, operating on an internal cadence that persists even when external signals are quieted. This internal timekeeping ensures that flowers open precisely when their preferred pollinators are active, and close tightly when the cold dew of midnight threatens to dissolve their delicate nectar reserves. As you rest quietly in the stillness of your room, consider how beautifully synchronized this silent world remains. The internal clock of a plant guides every phase of its existence, from the rhythmic opening of evening blossoms that fragrance the night air, to the closing of petals that shield fragile pollen until morning. Without any noise or effort, billions of leaves and flowers across the globe follow this peaceful internal pulse, surrendering smoothly to the restorative darkness of the night. Every leaf folded in shadow, every stem relaxing into the earth, exists in complete harmony with the steady flow of time. There is a deep comfort in knowing that nature carries its own quiet wisdom, keeping time even in the dark. Allow yourself to settle into that same natural rhythm, feeling the heavy, soothing weight of dusk wrap around you as your body relaxes and your thoughts drift into a gentle, dreamless sleep. As twilight gently settles across woodland paths and quiet garden borders, the architecture of blossoms reveals a series of subtle, exquisite adaptations designed to conserve the peaceful energy of the living world. High among the leafy branches of the horse chestnut tree, Aesculus hippocastanum, clusters of delicate flowers unfold in late spring, displaying bright central nectar guides designed to welcome passing insects. The delicate petals hold themselves still in the cooling evening air, releasing a subtle perfume that drifts faintly on the gentle breeze. In 1877, German botanist Hermann Müller documented that the central yellow markings on horse chestnut Aesculus hippocastanum blossoms shift to a quiet crimson after pollination, softly signaling to foraging bumblebees to visit neighboring unfertilized flowers. This silent, elegant shifting of color acts as a tranquil pathway of guidance, ensuring that heavy, pollen-laden bees do not waste their precious energy alighting upon blossoms whose fertilization is already complete. The tree manages its interactions with remarkable restraint and economy, inviting each winged visitor to move effortlessly from bloom to bloom across the leafy canopy. With every gentle change in pigment, the plant maintains a rhythmic, unspoken dialogue with the surrounding air, guiding tiny wings through the fading light with understated grace, ensuring that no effort is squandered and every blossom receives its peaceful turn. In a similarly serene display of biological resourcefulness, winter flowers adapt their physical forms to meet the quiet demands of colder seasons. Long after summer's heat has faded into memory, the Christmas rose, Helleborus niger, opens its luminous petals against the cool, sleeping earth, waiting patiently for the rare pollinators of late winter. After fertilization occurs in late winter, the snow-white sepals of the Christmas rose, Helleborus niger, do not wither, but synthesize chlorophyll and turn pale green, transforming into photosynthetic leaves that harvest weak sunlight to nourish the maturing seeds. Rather than relinquishing its delicate structures, once its initial task is finished, the plant gently repurposes its floral envelope, turning what was once a bright beacon into a quiet engine of growth. Over weeks of quiet transformation, the sepals grow sturdier, extending the life of the bloom long after standard petals would have fallen away to the damp leaf litter below. These green sepals continue to work steadily through the dim days of early spring, absorbing the low, angled light of the afternoon sun to fuel the development of new life beneath the lingering frost. It is a slow, self-sustaining harmony where nothing is cast aside prematurely, allowing the plant to sustain its offspring even when light and warmth are sparse in the quiet woodland. These subtle floral transformations remind us of the profound, calm efficiency woven throughout the natural world, where every shift in tone and structure serves a peaceful, nurturing purpose. Whether transitioning from brilliant yellow to soft crimson beneath a warm sky, or shifting from pure white to verdant green in the chill of late winter, blossoms carry out their cycles with an unhurried, quiet precision. They ask nothing of the surrounding world except time and space to complete their gentle work, offering a timeless rhythm of conservation, renewal, and quiet endurance. As the night deepens and the air cools, these flowers rest peacefully in their sheltered bowers, their steady work unfolding in total stillness, wrapped in the comforting silence of the resting earth. As the afternoon light fades into the quiet hush of dusk, the grand cycle of pollination reaches its gentle completion across the forest floor and open meadow alike. Where blossoms once reached eagerly outward toward light and air, inviting wind and wings with silent resonance. A subtle inward shifting now begins across every stem and petal. The vibrant work of attraction is finished for the season, and the plant turns its quiet focus entirely toward protection, nurturing, and restful preservation. Petals that once flared wide in luminous color begin to curl softly inward, their initial purpose fulfilled, folding away like worn silk under the cool evening air. The energy that previously flowed into sweet scents and rich nectar now recedes smoothly, moving downward through the stalk and root system into the deep, silent earth below. In this slow, unhurried transition from bloom to seed, nature demonstrates an enduring patience, reminding us that every period of outward activity is naturally met with an equally essential season of stillness, solitude, and profound quiet. This inward turning manifests in exquisite, deliberate movements throughout the botanical world, as the bright architecture of the bloom yields to the quiet, internal work of seed assembly. Following successful pollination, the slender stem of the ivy-leaved cyclamen, *cyclamen hederifolium, winds inward into a tight spiral spring, drawing the ripening seed capsule down to rest safely in the cool shade of damp woodland soil. This delicate mechanism of coiled tension gracefully lowers the precious offspring directly to the dark, moist carpet of moss and fallen leaf litter below, shielding it from hungry creatures and dry summer winds, while ensuring the seeds are placed precisely where they can find sanctuary. It is a slow, rhythmic dance of descent. A plant gracefully bending low to return its future generation to the dark, protective comfort of the ground. Each spiral coil tightens without the slightest hurry, taking days or even weeks to bring the seed pod into full, gentle contact with the earth, embodying a peaceful trust in the surrounding stillness. As twilight deepens and darkness settles completely over the woods and peaceful fields, all the varied mechanics of flower, stamen, and fruit sink softly into undisturbed repose. The night air grows still and clear, filled only with the faint, comforting fragrance of damp soil, moss, and resting foliage. Throughout the shadowed understory, countless seed heads now lie cradled close to the earth, tucked safely into warm crevices, while dormant roots and buds wait patiently beneath the surface for cycles yet to come. The grand mechanics of life, the delicate exchange of pollen, the quiet coiling of stems, the soft fading of petals, all subside into a deep, restoring stillness. Breathe in the cool, quiet air of the evening, and let the slow, steady rhythm of the natural world soothe every lingering thought. Here, in the soft embrace of the night, the earth holds all living things safely, inviting the world to let go of the day, sink into the darkness, and rest deeply.